quick video for you on calculating ionic charge. So remember that this keyword ion, just get my little highlighter, ionic charge, we're talking about ions. Ions are atoms that have lost or gained electrons. Because of that, they're not balanced. They don't have the same number of positive and negative charges anymore. So they're left with either a positive charge overall or a negative charge overall. To determine this, it's different for each element. So we need to first have a look at the number of valence electrons. So there's an important point for us. The number of valence electrons tells us what the ionic charge will be. From that, we can determine how many electrons that element will gain or how many it needs to lose for it to be a content, happy little element. Remember that our elements want to have a full valence shell. Now, valence are the electrons in the very outer shell. We call it the valence shell, and we refer to the electrons in that shell as the valence electrons. These elements want to have a full valence shell. Now, the elements that we're discussing can actually only hold up to 8 electrons in their outer shell. So that's what we're working towards. So you can see in the first example, if I just take off my little highlighter tool, the first example we've looked at lithium. Now let's quickly look at lithium on the periodic table. Here it is. Here's lithium. I'll just circle lithium. Up in this top left-hand corner. Oops. So lithium there has an atomic number of 3, which means it has 3 protons, it has 3 neutrons, it has 3 electrons. Now we know that there are 2 electrons in our first shell. Because of where the lithium is positioned here in this first group on our periodic table, we know that there's 2 in the first shell that's full. That means lithium has just 1 electron in its outer shell. It's got 1 valence electron. We can see that here in our table. It's got just 1 valence electron. How many electrons would it need to gain to have a full shell? It would need to gain 7. We don't even bother writing that in here because it's just unrealistic for that that element to be able to gain 7 electrons to fill its outer shell. It wouldn't happen for this lithium atom. What it can do, however, is it can lose one of its electrons. If it gets rid of 1 electron, then it's got a full outer shell. But if it gets rid of 1 electron, let me grab my pen. Oops, a little pen. So if it had 3 electrons and 3 protons, but we've gotten rid of 1 of these electrons, and now it's just got 2 negative charges and 1 positive charge, 3 positive charges, that's a difference of 1 positive charge. So we get left with 1 of those. Hence, the ion name that we form is lithium with a positive symbol there. And it's a superscript, which is important to note. Remember superscript? You can do those using this little button here. You can do a subscript when you're talking about the number of atoms. You can do a superscript when you're talking about the charge. Here, our lithium has a superscript of 1 positive symbol, meaning that it's got a positive charge of just 1. Our positive ions are cations, so that's why we've got this name here after it. On the contrary, our nitrogen, now where does our nitrogen live on our periodic table? It lives over here. Let me grab my pen again. Nitrogen lives here. How many spaces away from the edge is it? 1, 2, 3. It needs 3. So it's got 7 as its atomic number, which means that it's got 7 protons, it's got 7 electrons. That's 2 in the first shell, and there's 5 left over that would go in the second shell. It wants 8 in this second shell to be full and content and happy. That means it needs to gain, oops, that's very messy writing, 3 electrons. That's feasible for the nitrogen to do. So here you'll note, in our little table, we've got number of electrons to gain listed as 3 for our nitrogen. It doesn't want to lose those 5 in its outer shell because that just is not an efficient way of doing things. That's why we don't even consider it. It's actually very hard it would take a lot of energy for an element to do that. If it gains 3 more negative charges, then our nitrogen will have a charge of -3, which is why we've got this little superscript of -3 up the top there. All right, so let's do our oxygen. Where does it live on the periodic table? Just next to nitrogen. It's got an atomic number of 8, 2 in its first shell. That means there's 6 in its second shell, or its valence shell. If it's got 6 in its shell, we note that there, put our little 6 in. How many electrons does it need to gain? It needs to gain 2, because it wants 8. I'm gonna include none there as well, because it doesn't want to lose all those 6 electrons. It just doesn't work for it. Which means that if it gains 2 negative charges, 2 electrons, our ion formed, now we just have to grab our little superscript button. Superscript. Oh, what did I do? Goodness gracious. Our superscript will be this is going well. -2. Oh, okay, cool. This is very easy. Oh, I superscripted the whole thing. Hold on a second. Back up, back up, back up. Hey, there we go. All right, take 2. Superscript, -2. Hey, we did it. It's a negative charge, which means that it is what type of ion? It's an anion, not a cation. So do I need to turn this off again? Oh, that's annoying. There we go. We got there. Calcium. I'll do one more example for you. Calcium lives here. Number 20, if you can see it there next to potassium. If it's got 20, it lives in this second column in under beryllium, magnesium, and then we have calcium. That means that in its outer shell, it's only got 2 valence electrons. How many does it need to gain? It would need to gain 6, so we don't even consider that as a possibility, but it could lose 2. So if it loses 2 electrons, it loses 2 negative charges, it's left with a positive charge of those 2. 2 plus. Actually, these should really be written. Let me switch these around. Coefficient should go first. I'm sorry I didn't pick that up sooner. So it's calcium 2 plus. It's got a positive charge. So what type of ion is that? It's a cation. We'll pick one more random one. Let's go with that chlorine. Now, where does that chlorine live on the periodic table? It lives over here, number 17. For you can see what I'm talking about. Chlorine lives there on the periodic table. It is number 17. It's got an atomic number of 17. Just one space away from being one of those noble gases, which means that it needs 1 little electron to fill its outer shell. It's got 7 valence electrons. It needs to gain just 1. That's why chlorine and fluorine, those elements over there are very active. We don't want it to lose all 7. That just doesn't make sense. So we're going to put none there. The ion that's formed is Cl, because that's our chemical symbol for chlorine. Put my superscript on. Minus. What does that make it? An anion or a cation makes it an anion, a negative ion. I hope that helps clarify things for you. Any further questions? Please just post in our Teams page, send me an email, or whatever works. Let me know.